Hello, fifth graders. We're going to begin a journey today in a branch of mathematics that plays a fairly big role in middle school math. This branch of mathematics is known as number theory. Now, you might think, well, isn't all of mathematics about numbers? Yes, but this phrase, number theory, has a specific meaning in mathematics. It means that we're simply dealing with whole numbers. But it's a little bit perhaps deceiving. You might have a sense now as entering fifth graders that we're going to have to deal a lot with fractions, and then pretty soon, not too long from now, you'll have to be able to deal with negative numbers. That's absolutely true. Middle school, a lot of middle school is about dealing with fractions and special kinds of fractions known as decimals, and then also negative numbers. But number theory only deals with whole numbers. No negatives, no fractions. So you might think for that reason, well, it's simple. I'm familiar with the whole numbers. I know how to count. I know how to add, subtract, multiply, and divide whole numbers. And that's true. You should feel a great deal of familiarity with the whole numbers. But there are some questions in number theory. I probably won't get to them in this video, but there are some questions in number theory that the greatest mathematical minds in history have not been able to answer yet. So even though we're dealing with numbers we're very familiar with, there can be some very interesting and difficult questions that we can ask about them. I'm not going to ask you to prove some things or disprove some things about numbers that the greatest mathematicians in the world have not been able to do yet, obviously, but you can understand the problem they're dealing with. So number theory is, I think, a fun and very interesting part of mathematics. Today, we're just going to sort of get out of the way two vocabulary words. The really interesting stuff probably won't come for a while, but we have to deal with this issue of factors versus multiples. I strongly urge you, as it says here, learn each definition today and forever. It would be sort of a little frustrating if months down the road you still don't know the difference between factors and multiples. So get it straight right now, and then we're going to be able to do other things with these concepts of factors and multiples. But we have to get those definitions down first. That's a process that is true throughout all of mathematics. Learn the definitions and then build from there with logical reasoning. Now, here's some good news. I firmly believe that within the realm of school, all of the subjects you'll be introduced to here in elementary school, pre-K through 8, and then in high school, and later on in college, or wherever your education takes you, mathematics might have the fewest number of vocabulary words to learn. There are all sorts of vocabulary words in history, science, mathematics. It's the number of them is pretty limited, but it's essential that you learn them perfectly and permanently. Factors and multiples both deal with multiplication. Now that's pretty obvious from the word multiple, that it relates to multiplication. Not as obvious with the word factor, but both words relate to multiplication, but they are sort of looking at things from the opposite point of view. First of all, as I said earlier about number theory, we're dealing with the whole numbers. And the whole numbers are 0, 1, 2, 3, 4, 5, 6, and so on. They never end. And now let's get into this distinction between factors and multiples by looking at some examples. And as we look at the examples, I will define each of those terms. Let's start with a number we're pretty familiar with, 12, also known as a dozen. And let's consider the factors of 12 and then the multiples of 12. Well, here's really the definition of factors. the factors of any whole number. 12 is a whole number. It's part of that set of numbers. Oh, by the way, this squiggly brackets right here, squiggly brackets on either end, that is indicating a set. A set is a collection of numbers, and often a set of numbers is infinitely long. It's impossible to list all of the whole numbers, so we indicate with the 3 dots that they go on forever in the way we know that they do. So that's just another little piece of symbolism. The set brackets, they're called, indicating simply a collection of numbers. So 12 is obviously a whole number. Factors. Factors are whole numbers that multiply to some given number. So when we are asked to identify the factors of 12, we're being asked to identify whole numbers that multiply to 12. And whenever you're asked for the factors of a particular whole number, there are always a limited number of them. There are not an infinite number of factors of 12. Because again, we're in number theory, so we don't have to worry about any fractions, simply whole numbers. Here's how I would recommend that you approach the question of what are the factors of 12. Start with 1 times 12. It's nice often when we list things in a systematic way, like least to greatest. Anytime you're asked to find the factors of 2 numbers, you can always begin with the number 1 and the number itself. 1 times 12, of course, is 12. And then, as I say, work your way toward the middle. Consider the other whole numbers between 1 and 12 and see if you can identify other pairs. And here's an important point. They always come in pairs, the factors of a number. Sometimes a factor will pair with itself. Maybe we'll see an example of that later. 2 and 6 are a pair of whole numbers that multiply to 12. The 2 comes right after the 1, so we ask ourselves, is 2 a factor of 12? And of course it is, and it pairs up with 6. So, as I said, I have students systematically work from 1 times the number and then go toward the middle until you're sure that you have them all. After 2 comes 3, so we can ask, is 3 a factor of 12? And of course it is. And it pairs up with 4. And there they are. You know, in this case, when we listed the pair 3 and 4, there's nothing in between, so we know we're done. There are 6 factors of 12 that come in 3 pairs. And I'm sure you knew this already, but realizing that what we call these pairs of numbers are the factors of 12. The multiples of 12, that's a different question. The multiples of 12 are, well, they answer this question. What is 1 times 12, 2 times 12, 3 times 12? The first multiple of a whole number is always the number itself. So the first multiple of 12 is 12. And then you can look at it in terms of multiplication or even addition. The second multiple of 12 goes up by 12 from there, and it's 24. But of course, it's also 2 times 12. 1 times 12, 2 times 12. And next comes 3 times 12, 36. And then 4 times 12. Or simply add 12 for a particular, if you have a particular multiple of 12, to get the next multiple of 12, add 12 to the one you have. So adding 12 here, we get 48. And of course, that's 4 times 12. We have down here 1 times 12, 2 times 12, 3 times 12, and 4 times 12. So now my question, ladies and gentlemen, how many multiples of 12 are there? Just to review, when we were considering the factors of 12, there were a specific limited number of them. There happened to be 6. There won't always be 6 factors of a number, by the way. That will vary according to the number. But the number of factors of a particular number is always what we call finite, not which is not infinite. Infinite actually means not finite. Finite means there's a limited number of them, and then we make it opposite by saying infinite, which means there's not a limited number, or in other words, they go on forever. So how many multiples of 12 are there? An infinite number. The list never ends. We can always then go to get the next multiple. This was 4 times 12, so we can indicate 5 times 12 and 6 times 12 and so on and go on forever. So, just like we did up here in the whole numbers, we could just simply, and actually we have to put at some point the 3 dots to indicate that it goes on forever in this way. So here is our first experience with the definitions of these two. Now, sometimes you get the definition just by understanding how it works with a particular number like 12, and then we'll do another one, and then you'll really get it just through those specific examples. In terms of just putting into words the definitions, to me it's easier with factors. The factors of a whole number are the whole numbers that multiply to that, right? In this case, the whole numbers that multiply to 12. In terms of multiples, it's a little harder for me to put it into words in terms of a definition, like if I were writing a textbook, what is the definition of multiples? I suppose one way to do it would be to say the multiples of any whole number are 1 times that number, 2 times that number, 3 times that number. That's a good enough definition. So I'll just leave it at that for now, and we'll look at a few more examples. Let's consider the factors and the multiples of 45. For factors, we can always begin with 1 and the number. 1 and 45. 1 times 45 is 45, and we'll work toward the middle. How about 2? Well, you should know by now, I think you immediately recognize that 2 is not a factor of 45. In fact, when we're very young, we take the whole numbers and sort of group them, cut them in half and look at 2 infinitely sized groups of whole numbers, one called even, one called odd. 45 is an odd number. Well, let's realize this. Maybe you haven't really thought of it quite this way before. Why is 45 an odd number? Because 2 is not a factor of it. There's no whole number you can multiply 2 by to get 45. That's what makes it odd. So I'm not going to put 2 on this list. The next number to consider is 3. And this is an interesting one for me, teaching 5th graders. I often say something like, you may not immediately recognize that 3 is a factor of 45, but if you think about it for just a few seconds, I'm going to ask you to come up with the whole number that you can multiply 3 by to get 45. And there is one. 3 is a factor of 45. So pause the video. If this isn't going to be enough time, pause it right now. I'll wait a few more seconds. 3 times. You can try some out. You can take a guess and then see if it works out. 15 is the answer. Right? Did you get that? 3 times 15 is 45. Now, the next whole number is 4. This is a true statement. If 2 is not a factor of a whole number, then 4 isn't either. Okay? The next whole number is 5. And do you recognize that 5 is a factor of 45? Well, you do, I bet. And if you recognize that 5 is a factor of 45, it could be because as a very young person, a very young mathematician, you could do this. We all learn this at a very young age. And the teacher probably doesn't have to spend that much time on it, whether it's in kindergarten, 1st grade, 2nd, whenever it is. We all know how to do this. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, right? And what do all those numbers have in common? They either end in a 5 or a 0. When we count by fives like that, starting with 5, 5, 10, 15, 20, 25, 30, 35, 40, 45, those are all the multiples of 5. 45 is a multiple of 5, which means 5 is a factor of 45. Now that's a relationship that's always true, and I hope to remember to look at that a little bit more specifically before this video ends, but 5 is a factor of 45, and it pairs up with what? What do you multiply 5 by to get 45? And the answer is 9. Now, ladies and gentlemen, those are all of the factors of 45. We already talked about 2 and 4 not being factors. Well, we've got 5 and 9 here. What about the numbers in between? 6, 7, 8? 6, 7, and 8 are not factors of 45. And now, I said earlier about 4. If 2 is not a factor of a number, then neither is 4, neither is 6, neither is 8. Maybe you can appreciate that fact. If not, then at least think about the 6, 7, and 8. Is the number 45 on the 6, 7, or 8 times tables? No. So we're done. Now the other question about the multiples of 45. Well, the multiples of any whole number are 1 times the whole number, then 2 times the whole number, then 3 times the whole number. So the first multiple of 45 is 45. That's one of the easiest questions you can ever be asked. What is the first multiple of a whole number? It's the number. That's 1 times 45. 2 times 45 is 90. Or if you prefer to think of addition, add 45 to the 45 and get 90. Now add another 45 here and you'll get 135, right? Adding 45 to 90 gives you 135. We'll do one more. If you add 45 here, you'll get 180. Right? Now, just to make this tie-in now, this connection to multiplication, factors and multiples are both related to multiplication. These, of course, going back to the factors, these are the pairs of whole numbers that multiply to 45. Notice they indicated the pair in there. And the multiples of 45 are 1 times 45, 2 times 45, 3 times 45, and 4 times 45. So there you are. We're going to next look at the factors and multiples of 36. But before doing that, I'd like to be a little bit more specific about something I said a moment ago, the relationship between the number 5 and 45. And I'm about to indicate a relationship that always works when you're talking about factors and multiples. So this is, I'm writing on the board here, but it's not about the factors and multiples of 36. I'm going to write here that 5 is a factor of 45. 5 was one of the numbers we indicated was a factor of 45. Now, this is, I'm about to introduce you to a concept which comes up in math a lot. It is a very important part of mathematics. And that is what we might call equivalent statements. Two statements that say the same thing in different ways. Or, let me put it this way. If one of the statements is true, the other one is true. Working both ways. And we have a symbol for that in mathematics. It's not the equal sign, because sometimes, the reason we don't use the equal sign for this is sometimes there could be an equal sign on either side of this other symbol. But it's kind of like the equal sign. It's saying that these two statements are equivalent, that one automatically leads to the other, and in both directions. So this idea of both directions, an arrow pointing both ways. So here it is, an arrow pointing both ways. That symbol means that the two statements that will eventually be here on the board both lead to the other one. If one is true, the other is true. Now, if I'd planned a little better, If I had more room here, I would have put it all in the same line, but I'm going to go down to another line here. And here's the other statement. 45 is a multiple of 5. Please understand, before you finish this video, some goals: understand the difference between factors and multiples, how to go about finding the factors of a whole number, how to go about finding the multiples of a whole number. And then also, another thing, realize that if 5 is a factor of 45, then 45 is a multiple of 5. And either one of those statements automatically means that the other one is true, right? Now, I have not written up here the multiples of 5, but I said them a little while ago. The multiples of 5 are 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. There's the 45. So you see, 45 is a multiple of 5. Well, that can only be true if 5 is a factor of 45. And if 5 is a factor of 45, it must also be true that 45 is a multiple of 5, right? All right, let's look at 36. Well, as I suggested, we will start with 1 times 36 and work our way toward the middle systematically, considering all of the possible numbers. 1 and 36. Those are factors of 36. 1 times 36 is 36. The next whole number after 1 is 2. Is 2 a factor of 36? Well, yes. We recognize 36 as what we call an even number. That means, when we say 36 is an even number, it means 2 is a factor of 36. It also means 36 is a multiple of 2. Remember that connection between factors and multiples. So 2. Now, you might not know immediately what you multiply 2 by to get 36, but think again, a few seconds. You can figure it out. Pause the video if you think you're going to need more time, because I'm going to say what it is very soon. Here it comes. 2 times 18 is 36. So I'll put 18 here. And it pairs up with the 2. Next, you ask yourself, is 3 a factor of 36? And a lot of us memorize multiplications through the 12s. It's not absolutely necessary that you memorize the 12 times table. If you can go from 0 times 0 all the way up to 9 times 9, all the single digit numbers, that's kind of enough. But the number 12 comes up in life. Eggs are still sold by the dozen. There are 12 months in a year. So it's kind of nice to know that 3 times 12 is 36, right? 3 is a factor of 36 because 3 times 12 is 36. The next whole number after 3 is 4. How do you know that 4 is a careful. It's easy to say the wrong word. Got to think about it. It's easy to realize that 4 is a factor of 36 because you've learned those multiplication facts. 4 times blank is 36. Of course, it's 9, right? 4 and 9. By the way, my planning here, I think, worked out pretty well. So far, we have, how many? 4 pairs, a total of 8 factors of 36 coming in 4 pairs so far. 1 is 36, 2 times 18, 3 times 12, 4 times 9. Now, the next whole number after 4 is 5, but 5 is not a factor of 36. We know that immediately. Why not? From that little song, that little sing-songy thing that we learn when we're very young. 5, 10, 15, 20, and so on. 36 ends in a 6. It does not have 5 as a factor. In order for a number to have 5 as a factor, the whole number would have to end in a 5 or a 0. So 5 is not going to go on this list here. Next comes 6. Is 6 a factor of 36? Yes, it is. You know that from your knowledge of the multiplication fact. So I'm going to put a 6 in here and then ask you, what does it pair up with? Where's the other factor that goes along with the 6? And of course, it's 6. 6 times 6 is 36. I wanted to make sure I gave you one like this. And what I'm going to say to you, I would not, if this were a quiz question and you put the 6 there twice, I wouldn't take off points for it, but we generally don't put it twice. If we're just listing the factors of a number, if we say 6, and then another 6 is also, it's the same number. We understand, however, that it pairs up with itself. They always come in pairs, but for certain special numbers like 36, it'll have a factor that pairs up with itself. And we are done. We've already said 5 is not on the list. There's between the 6 and the 9 is a 7 and an 8, but 7 and 8 are not factors of 36, simply because 36 does not appear on the 7 or 8 times tables, right? When we learn 7 times what is 36? Well, there's no whole number, and the same thing for 8. So we're done with the factors of 36. The multiples of 36 begin with 36, 1 times 36, and then 2 times 36, and so on. 36, 2 times 36 is 72. If you add 36 and 36, you'll get 72, or simply 2 times 36. Add 36 here, and you will get 108. Right? Can you visualize that? 108. And 108 is 3 times 36. We won't go too far with this. Adding one more 36 here is not that difficult. 108 plus 36 would be 144. And that, let me just indicate down there, 1 times 36, 2 times 36, 3 times 36, and 4 times 36. And I would not expect you to come up with those multiples as quickly as I did necessarily, but I would expect you to come up with them in a reasonable amount of time on a quiz, a few seconds or a minute or so. And then, of course, put the 3 dots. So on a quiz, I might ask you, what are the first 4 multiples of 36? These are the first 4, right? And there are an infinite number of them, so we can never list all of them. One more, I'd like to close this video with 2 considerations. We're going to close by considering the factors and multiples of 17. But before we do that, down here, I would just like to emphasize this point again, the same point that I made with the whole numbers 5 and 45. I would like you to believe, you should believe, that 7 is a factor of 42. How do we know that? We know it immediately from our long-term memorization of the multiplication facts, which is a very important skill for entering 5th grade. And if you have not yet memorized all of the multiplication facts from 0 times 0 up to 9 times 9, then you better do it as soon as possible, because it's always going to be something that might hold you back, even if it's for a few seconds, to think about a particular multiplication. What is 7 times 6, for example? If you have to think about that for too long, you could get lost in a more complex problem in middle school. And so I just revealed what 7 pairs with to get 42. Or in other words, I've answered the question, why is 7 a factor of 42? Because 7 times 6 is 42. It would pair up with the 6. We're not going to list all the factors of 42, but you can believe that 7 is a factor of 42, right? See if you've learned yet this relationship. If we know that 7 is a factor of 42, what do we also know? Other than the fact that the 7 pairs with the 6, not that. But what else do we know? How can we sort of say the same thing? 42 is a blank of 7, right? Those 2 statements will always go together, and in the blank is the word multiple, the other word, right? 7 is a factor of 42, and we have that double arrow there, which means that if you have this statement, you have the statement below it, and if you have the statement below it, you have the statement above it. And often it will be written all on one line. Again, I don't have enough room, and I just drop the marker. So we come back here and quickly write in 42 is a multiple of 7. Right? If you truly believe that double statement there, then you've accomplished the goals of this video. 7 is a factor of 42. Automatically means that 42 is a multiple of 7. And because 42 is a multiple of 7, that automatically means that 7 is a factor of 42. And of course, the 7 is pairing with the 6 as far as the factors are concerned, right? So let me ask you this question. See if you can figure this out. Which multiple of 7 is 42? Think about that for a moment. If you're not sure what I'm asking, so down here we're talking about the multiples of 7. Right? So we've got those two words, factor and multiple. 7 is a factor of 42, and automatically that means that 42 is a multiple of 7. So multiple of 7, let's start to consider those. The first multiple of 7 is 7. 1 times 7. The second multiple of 7 is 14. And the multiples of 7 are the 7 times table, right? And the third multiple of 7 is 21. 3 times 7. So I bet you can answer it now. Which multiple of 7 will give you 42? And of course it's the 6th. The 6th multiple of 7 is 42, and that takes us back to this statement that, which number pairs with the 7 as a factor of 42? It's the 6th, right? So just to remind you, finish this out. 28, 4 times 7, 35 is 5 times 7, and 42 is 6 times 7. 1, 2, 3, 4, 5, 6. First, second, third, fourth, fifth, sixth multiple of 7 is 42. All right, so let's close with the number 17. And this is sort of big word with a funny spelling, segue. It's not S-E-G-W-A-Y like you might think. Oh, and now I gotta, maybe I should tell you the spelling. It's kind of a funny spelling. Is it S-E-G-U-E? I should have been prepared. Ask me in class. I know I'm the math teacher, but all of us in the middle school try to support each other, and the learning of words is very important. So remind me about this word segue. It's pronounced like it's S-E-G-W-A-Y, but it isn't spelled that way. And a segue is something that leads into something else, right? So as soon as I started making this current video, I had planned that I would end with a number like 17, and that's going to lead into the topic of the next video. It's going to be a segue, and we'll look up in a dictionary how to spell that word segue. Even though it's a sort of a sophisticated word, you young people probably don't use it that much, and it's got a challenging spelling, but it's a very, very simple concept. One thing is sort of an introduction or leads into something else. That's what a segue is. So the 17 is going to be a segue to the next video, and really because of the answer to the first question. What are the factors of 17? So you think about that for a moment, and what have I advised you to do always when considering what the factors of a number are? Well, to begin with 1 and the number. And then to work your way toward the middle. Do you have any thoughts? Do you have any suspicion? Go ahead and take 5 minutes. Take 10 minutes to come up with the other factors of 17. Now remember, we're in number theory. When we're talking about factors, we're only considering whole numbers. So take as much time as you need to come up with the other 2 whole numbers besides 1 and 17, then multiply to 17. You still thinking about it? There aren't any. The only two numbers that multiply to 17, whole numbers that multiply to 17, are 1 and 17. That makes 17 special, along with an infinite number of other whole numbers. And there's a name for a number like this. If you don't already know it, maybe you can try to find out from some other source besides me, and then maybe in class we'll share. What do we call a number like 17 whose only two factors are 1 in itself, that doesn't have any other factors? And this name for it is not something that's just, oh, we got a name for it. No, they're extremely important. Numbers like 17 are extremely important in mathematics, in number theory, and we're going to explore that more in the next video. Now, so really, let me come back up here. I don't want to mislead you to think that there's some numbers in there. So now we can just put them very close to each other because there are no others. There are still, however, an infinite number of multiples of 17. The first multiple of 17 is 17. 1 times 17. 2 times 17 is 34. That's not too hard, I don't think, for a fifth grader to come up with. You could have done 2 times 17, or simply add 17 to 17. Now, if you add another 17 to 2 times 17, you'll get 3 times 17, which is 51, is 3 times 17. We'll do one more. This is pretty easy. Add another 17 to 51 and get 68. So down here we have 1 times 17, 2 times 17, 3 times 17, and 4 times 17. How many multiples of 17 are there? An infinite number. So we'll put the 3 dots like that. Ladies and gentlemen, it's been a pleasure to make this video. I hope you've enjoyed it. Please learn the difference forever between factors and multiples. So long for now. See you soon.